let's say that we had a function f of x equals x squared, which we can draw on a grid. And let's say that we were interested in finding the area under this curve from, say, x equals to 0 to x equals to 1. How would we do this? Well, we can apply the fundamental theorem of calculus, which tells us that if we integrate our function x squared with respect to x from 0 to 1, this will equal the area under the curve. This tells us, applying the fundamental theorem of calculus, that we need to find the antiderivative of f of x at 1 and subtract from that the antiderivative of f of x at 0. So how do we find the antiderivative? Well, let's go over to the side here and just review a couple of concepts. The derivative and the antiderivative can be thought of as opposites of each other. So let's say we had a function f of x equals x squared. We know that if we were going to find the derivative of this function, it would equal 2x. The power rule tells us to take the exponent, multiply it by what's in front, and then subtract 1 from the exponent. So if we had the same function, f of x equals x squared, and wanted to find the antiderivative of this function, we'd do the exact opposite. We would add 1 to the exponent first, then divide by this value. And this would leave us then with x cubed divided by 3, which becomes the antiderivative of x squared. We end up with a progression. So you have the function x squared, and its derivative becomes 2x, and then its antiderivative becomes x cubed over 3, such that the derivative of the capital F function is the small f function, and the derivative of the small f function is the f primed of x function. Okay, let's come back now and finish off our problem. We know that the antiderivative of x squared is x cubed over 3, and what we want to do here is then substitute the value of 1 in for the antiderivative, and then we want to do the same thing for at 0. And what we end up with is 1 cubed, which is 1 divided by 3, which is equal to 1/3, minus 0. So the area under the curve of x squared from 0 to 1 is 1/3, whatever the units may be.